now we're gonna do finding the height of the tide at any given time. So if you were to be told any time of the day, of any day of the year at a given location, what would be the exact height of tide right then and there? I picked arbitrarily February 25th at 10:33, and we're gonna be using Little Creek, Virginia. Once again, I'm hoping that's a substation. If it's not, we'll just pick something that's like nearby it on the index. I'm going to do the full process, and this process begins by just finding the substation information like we did in the previous video. So I'll probably leave a timestamp if you want to just jump ahead straight to the new stuff. But if you want the practice, we'll go through everything like we did before. So step one is we head to the index, looking for Little Creek. So the index is 115. We scroll down. That's too far. Here's the L's. Little Creek, Virginia, cool. All right. Little Creek, Virginia is 2433. So write reference number 2433. So now, using that information, we can head to the substations. Oh. Guessed randomly and I got pretty close. So here we are in the 2000s for the substations. 2, 3, 2, 4, 3, 1, 2, 4, 3, 3, Little Creek. Specifically the railroad terminal. And you can see that they might have, like for other ones, there might be specific substations off of the same name. So you could have Lynnhaven Bay, Long Creek, Brown Cove, Buchanan Creek. They'll all be categorized under Lynnhaven Bay, but you can still make them out specifically. But we'll use Little Creek. So now we need to get their information. Number one, they're based off of Hampton Roads. We'll write that down. Picked this because I'm in Hampton right now. And now we use the correction factors. So you can see for Little Creek, wish you would highlight. Okay. Their times, minus 48 minutes, minus 50 minutes. I gotta set up the table first. Okay. Okay, so minus 48 minutes, minus 50 minutes. So high and low tide both occur about 50 minutes earlier in Little Creek than they do at Hampton Roads, which makes sense because it's closer to the ocean. Then we'll see plus 0.1 and 0.0. It's interesting that it was just such a small correction factor, but okay. So high tides at Little Creek are 0.1 feet higher, and low tides are exactly the same. There's no difference. Good. Now that we have the correction factors, we can come to Hampton Roads to get our actual information. So you come back here. I'm gonna guess 30 and hope I got the right, but close. New London, Connecticut. So that's not necessarily close, but we got to come down the line now. Bridgeport, Connecticut. Wow. Sandy Hook, New Jersey. Hampton Roads. Philadelphia. Just want to check something. Okay. Hampton Roads. And we are looking for, I believe, February 25th, I said. All right. February. And here's the 25th. So, here's the information for February 25th. And if you remember what I said in the previous video, you if you're trying to find just the high or the low, you technically only need to take one of these if you know it's going to stay within the same day and still answer the question you're looking for. For this one, though, for height of tide at any time, you need at least two. Because if you remember way back at the beginning of these videos, I said that you need the duration of tide from low to high or high to low, and you need the range of the tide from its high water to its low water, the difference in feet. So technically, you need two. Now, we just saw that some of these might move out of the day. We're looking for exactly 10:33, so it's between these two, but it is possible that maybe these times will all shift to the point that it's not between these two, it's between these two or these two. So for that reason, I recommend bringing everything over and just doing the work for all of them, just in case this stuff all shifts positions. Because if it does, you're going to end up doing more work than you would have had to otherwise. So we're going to copy all of this over at, let me make the table again. I'm going to make it a little bit neater this time. So, Hampton. At 0:58, we have a height of tide of minus 0.4 feet. Then at 7:24, it was just misprinted. Remember, they should always be about 6 hours apart. That's why I caught myself there. There should never be a high and a low that are an hour away from one another. It has a height of 2.5 feet. So the range of tide is not that big here. Then at 13:46, we've got minus 0.4 again. So 13:46. And at 19:51, we have 2.5. Don't know why these keep coming out to be the same numbers. They're usually off by 1 or 2 tenths of a foot between the two highs and the two lows. So now we put in our corrections. And after our corrections, we'll have Little Creek. So, our high tide corrections, remember, first you find the two high tides, are minus 48 minutes, and then plus 0.1 feet, Our low tides, these two, are minus 50 minutes, and plus nothing. Remember, don't get these mixed up. Make sure you know you're applying your high corrections to your high waters and your low corrections to your low waters. Don't want them confused. So now you come across, you see the first low water is at 058 in Hampton. So if we apply our correction, it's at 0008 with no change in the height. So it's still minus 0.4. Our first high water is at 724. Subtract 48 minutes. So God, 6, 20, wait. Zero 636. See if we add 8 minutes, like it's 240. Yeah, okay, good. I'm proud of myself there. 1346 minus 50 minutes will be 1236. No, 1256. Yeah, 1256. And its height does not change either. I also forgot to do the height here. Plus 0.1, so we get a height of 2.6. 1951 minus 48 minutes. God damn it. 1903. I hate math. And 2.6 feet. Okay. So now we have the two true times of high and low water at Little Creek. Remember, we are looking for 1033. So the first thing we need to do is we need to pull out the two times that are relevant to us, which are just the two times that fall on either side of 1033. So we've got 636 and 1256. And at 636 is the high, 1256 is the low. So if we were to draw this out, what that means is that the time graph looks like this. Here, we have 0636. Here, we have 1256. And then the heights, this is 2.6 feet, and that is minus 0.4 feet. So, like I said in previous videos, all the information we need is the difference in time between these two, the duration of the tide from high to low, the range of the tide, which is the total difference in height between the high and the low, and then the time to the nearest high or low. So we're 1033. We're somewhere in the middle here, 1033. Now we just need the difference in time between it and whichever the closest is. And just off the top of my head, 1256 should be the closer one. So then what that means is basically, to simplify the graph, if we have this and this, and we have this, with this being the desired time, if we compare the proportion between these two, we can get the proportion between this and whatever this will be. And then we'll be able to apply it backwards and get the height at that exact time. That's a simplification because that's almost making it linear. When it's not linear, it's a sine wave, but that is fundamentally how it works. So we need three things. We need the range of the tide. We need the duration of the tide, and we need the time to nearest. So the range of the tide, like I said, is just the difference between the height of the high and the height of the low. Because these are both negative, we can add, or because one is positive, one is negative, the total distance we get by actually adding them together. If this was 0.1 and it was positive, we'd subtract the 2. But in this case, we get to add them. So 2.6, I'll write it out. 2.6 minus negative 0.4, or plus 0.4, gets you 3.0. So our range of tide is 3.0. Our duration of tide is the change in time between the high and the low, or if this was the other way from the low to the high, if the low happened to be the one that happened earlier. So 0636 to 1256. In this case, you do subtract, and you take the larger number first to 0636. That gets, well, obviously 6 hours to go from 6 to 12, plus 20 minutes. So 0620, 6 hours, 20 minutes. Now time to nearest. You take whichever one is closer, which I'm confident is 1256, and you find the difference between that and your desired time. Now remember, if we were closer to 0636, if we had picked like 8, for instance, it would be 8 minus 0636, because, take the larger, subtract the smaller. In this case, though, we're closer to the later on time, so we take the larger, subtract the smaller. So if we do this, 56 minus 33 is 23, and 12 minus 10 is 2. So 2 hours and 23 minutes is our time to nearest. 6 hours, 20 minutes is our duration of tide, and our range is 3. So now with that information, we can finally come back to the book, and we can look. What did I say the number was? Is it 115? Might be further. Oh no, that's too far. It's the index. I had it written down somewhere. Anyway, should be able to scroll up relatively quickly. Here it is. 235. Okay. Now we finally come to our table. And for this one, I am definitely going to use a straight edge because this is very easy to get. Oh yeah, here's the receipt I was using for the bookmarks. So we're going to use this table having plugged in the numbers that we just found. And the way we do this is you go, think of it as step 1, step 2, step 3. So first, you line yourself up based off of the duration of the tide. So you pick a row you're going to move off of based off of this scale here. Once you've picked a row, let's say this one, you then follow that row across until you hit a time to nearest that is close enough to yours. So you're following this one and you get to here. Maybe you're following this one and you get to here. It doesn't matter. At whatever point where you catch a number that's close to yours, then you're sticking with this column. You follow this column down, continue it until this column lines up with a range of tide that you're looking for. If your range of tide was 10, you'd follow the column all the way down until you hit 10, right there. And then this number right here would be your correction factor. We'll get to that in a second. So we'll try that with the numbers we got. Let's see. So starting with the duration, because that's the first one we use. 620, 223, and 3.0. 620 duration, 223 time to nearest, range of 3. So we're going to come here. And luckily for us, I didn't plan this ahead. We actually got 620 perfectly. You can see it's broken up into fat units of 20 minutes. So 620. Put this here so we don't lose our spot. You follow the 620 row until you get a time to nearest that is as close as you can get to 223. So you can see the row comes across until right there, 219. There's our number. So now we've picked 219, doesn't matter anymore. This column is what matters. So now we need to stick with that column. So we're going to set our bookmark like this. And we scroll down, staying along that column. Now we need to find our range of tide. You said our range of tide was 3. So here's 3. We need to get where this range of tide intersects our column. So we follow the three row across, and we get 0.9. So to review, duration of tide of 620, follow the row until you get your time to nearest, which for us is 223, but our closest number is 219. So you stick with 219. You follow that column straight down. You take the row of your range of tide, follow it across until you get to 0.9 is our correction factor. So that's how you use the table there. And now that we have that, we can come back to our page and write down our correction is 0.9 feet. So that 0.9 is, it's not actually a factor because it's not multiplied, it's a correction. It doesn't say plus or minus because that's up to you. In this case, we're starting from a low tide, meaning anything that happened before the low tide was higher than it. So we would add. If you had done all this math, but you were actually looking for 2 hours, 23 minutes after the high tide, if your desired time was somewhere up here, this would all still come out to the same because the curve is mirrored from bottom to top. So you would still get a correction of 0.9 feet, but now it would be off of the high tide because it's just based off of whichever one is lower going towards the next one. So in this case, it would be 0.9 feet below the high tide. In our case, it's 0.9 feet above the low tide. We're working backwards to our point in time right here. So that means that we're going to take the 2, and because this is a negative, we're going to add them. In this case, it'd be subtracting. Either way, you just have to move upwards. So our height was negative 0.4 feet. So negative 0.4 plus 0.9 gets positive 0.5 feet. And that's your answer. At 10:33 on February 25th, 1983, in Little Creek, Virginia, the height of the tide will be 0.5 feet exactly. And that's how you do this whole process. So you start with whatever your specific substation is. You look it up in the book through the index. You find both its main station and its correction information. You get the information from the main station. You apply the corrections to it to get the information on the substation. Then, having gotten those, you come and you calculate the 3 things you need: your range of your tide, your duration of tide, and your time to nearest. You find what each of them are. Then you take those 3 numbers. You go to your time, height of tide at any time table, and you use them all. Follow the steps through the table, and that gives you your correction factor. And then you apply that correction factor to the same point in time that you used your time to nearest value from. And that will give you the true time, the true height of the tide at that time.